Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good night, everyone. Alhamdulillah wassalatu wassalamu ala rasulillah wa ba'd. My name is MohammadHafizhAyatillah, and today we will walking you through one of the core features of cloud computing on Alibaba Cloud, which is autoscaling. So this presentation covers the concept, the underlying functions, and the key components that make autoscaling work. So first, let's talk about the agenda. So here's how we'll go through this. We'll start with how scaling actually is and why it matters. Then we'll look at its two core functions, which is health check and scalability. There are some typo here. And after that, we'll break down the components, both structural and operational, and we'll cover a few technical considerations that are easy to misunderstand, and summarize the operations available for each component, and close with a short conclusion. Okay, first, what is autoscaling? So autoscaling is a service that automatically adjusts the number of compute resource, such as ECS instance or container instance, or we also call it ECI, based on predefined business conditions without any manual intervention. So why does this matter? Why does this matter? Without it, you're stuck choosing between two bad options. First, over provisioning, which wastes money and idle resource, or under provisioning, which risks downtime during traffic spikes. So autoscaling solves this through two independent trigger paths: metric based, which react to real-time conditions like CPU usage, and schedule based, which acts proactively at predetermined time. So I have some visual here. The visual is for the next slide. Okay, next slide is two main function of autoscaling. So autoscaling runs on two main functions. The first is health check, which is essentially self-healing. It periodically checks instance status, and if an instance goes unhealthy or times out, it replaces automatically. If that instance later recovers, it's brought back and the extra one is removed. So I have some visual right here. When an ECS is unhealthy, as you can see, the health check receives a response indicating that an ECS is unhealthy, or no response at all. So the unhealthy instance or ECS is moved to a timeout. So here it will self-recover itself until the status is healthy and come back. While the unhealthy ECS goes to timeout, a new ECS is spun up to take the place of the unhealthy ECS instance. Like this one, it marked with the blue color. And then next, we'll talk about the scalability, the second core function. So scalability adjusting instance count based on actual demand. When the demand goes up, the system scales out. When it drops back to the baseline, it scales in. And scale in isn't optional. It's what actually makes this cost efficient. So there are visual right here. And the first thing that you have to do is to pre-configure the baseline. So it will trigger the alarm. So when the demand is high or hitting some spikes, the system will scale out. And when the demand is lower than before, it will scale in under the baseline. Okay, next, let's talk about the structural components, container and blueprint. So let's look at the two components that define the structure. First is scaling group. So scaling group is the main container. It holds the minimum maximum and expected instance number. And it can automatically integrate with a load balancer and database whitelist. The second is scaling configuration. So this one is the blueprint for a new instance. The image, the spec, the disk. One group can have multiple configurations, but only one is active at a time. So, and here's the part that often get missed. When you change the configuration, so it doesn't affect the instance that are already running. The effect will only hit the new one, not the instance that are already running. Okay, here's some visual about the operation of scaling group. First, automate the adjustment of computing power of specific type based on business requirement and scaling policies. And next, check and update the scaling group attributes such as the maximum, minimum, and expected numbers of instance. Next, enable or disable a scaling group which has an instance configuration source, and then remove the scaling configuration, scaling rules, scaling activities, and scaling requests related to the scaling group. Okay, next, the operation of scaling configuration. These are some visual about it. So a template based on which ECS instances are automatically scaled out, and then check and update the scaling configuration of the ECS type, which is crucial when you set some new configuration, and then removing a scaling configuration. Okay, next, let's talk about the operational components, logic and execution. Now the components that drive execution. First, there are scaling rule, define the action at instance, remove instance, but it stays passive until something triggers it. And then there are scaling activity, which the actual record of what happened with the status of successful or failed or rejected. Next, scaling task is the bridge between cloud monitors matrix and auto-scaling rules execution. And cooldown time is the window after an activity completes, where the system pauses to prevent repeat back and forth scaling, also known as flapping. Next, the important technical consideration. A few details here are easy to get wrong. First, a scaling activity can't be interrupted mid-process, and if it partially fails, the system prioritizes the integrity of the instance over the integrity of the activity itself. Second, a scaling rule is always capped by the group's max and min size. It can never override that boundary. And the last one is the most commonly misunderstood, which is cooldown time only blocks alarm triggered activities from Cloud Monitor. So manual execution and scheduled tasks are not blocked by cooldown at all, without exception. Without exception. Next, these are summary of operations per component. Just to summarize the operation available across components. First, scaling groups support create, modify, cascading, delete, and enable or disable. Next, scaling configuration and scaling rules support create, modify, and delete. And then triggering tasks, add two more, execution, attach, which restart instance stop under economical mode. And the final one is schedule tasks. Follow the same as scaling configuration and scaling rule, create, modify, and delete. Okay, the final one is conclusion, the final slide. So to wrap up, auto scaling combines health check and scalability to deliver automatic elasticity. Its components are hierarchically dependent, with the scaling group as the main container. There are two independent trigger paths, which is metric based and schedule based, and understanding details like cooldown, scope, and rollback behavior is essential to implementing this correctly. So thank you so much for listening my presentation. Assalamualaikum warahmatullahi wabarakatuh.